So children, welcome back to session 4. This is video 6 and we are learning chapter 1, real numbers. Well, before we proceed in this session further, let's see what we learned earlier in the previous session. Milli. Now you must be familiar with this word. It is abbreviated form of most important lesson learned yesterday, means in the previous session. So what we learned? We learned division method of finding LCM. Do you remember? We found the prime factors of two numbers or even three numbers. If you have to find LCM of three numbers, we take them together and find the prime factors simultaneously. Viewing LCM at 40 degree. Nothing as such is given in mathematics. It's my way, my trick of making application in that particular word problem. Next, viewing LCM at 77 degree. Here also we make application, right? This is basic, definition of LCM. And here, if you remember, a number is product of two, a number is product of two, that number is same, then that number is LCM of those two. Anyway, that you can go back and see the previous video. Alright, so what we are going to learn today in this session. Alright, just two things. First, finding HCF by yet another method, and that is Euclid's division lemma. Do you remember Euclid's division lemma? Good. Alright, fine. How to find LCM by Euclid's division method. Children, for that we'll have to revisit division, which you learned in standard 5th. Are you good at division? Well, most of you may say yes, some of you may say no. So it's very important that we have a small session, a part of the session for division practice. Alright, so let's divide a few numbers. Question. Divide. First, 6, 4, 9, 8, 0, 3 divided by 23. Second, 92891 divided by 92. And third, 69750 divided by 153. Okay, children. Well, please have patience. To those I'm telling who knows this well. Pay attention, something new you will learn here, some tricks you will learn here to divide, okay? So first division is 49803, that is divided, and you have to divide by 23. The divisor is two-digit number, so you should know the table of 23, which you do not know. So what you will do? Prepare a table? Yes, possibly if you want. 23 ones are 23. Then what is 2s are, 3s are, 4s are, 5s are, 6s are, 7s are, 8s are, 9s are, 10s are, you know, 23 10s is 230. Below, just multiply. 2 3s are 6, nothing is carried over. 2 2s are 4. So 23 2s are 46. Now 23 3s are 3 3s are 9. Nothing is carried over. 3 2s are 6. So 23 3s are 69. 4 3s are 12. This time 1 is carried over. 4 2s are 8 and 1 9. Cancel this. 5 3s are 15. 1 is carried over. 5 2s are 10 and 1 11. 6 3s are 18, 1 is carried over. 6 2s are 12 and 1 13. Next, 7, cancel this. 7 threes are 21. 1 here and 2 is carried over. 7 twos are 14 and 2 16. 8 threes are 24. You cancel this. 2 is carried over. 8 twos are 16 and 2 18. Next, cancel this. 9 threes are 27. 7 here, 2 is carried over. And 9 twos are 18 and 2 20. Now in this 207, just add 23 and see. 10, 3, 2, which is 23 tens. You are getting it, correct? This last test is just to make sure that you did not make any multiplication mistake here. So this is how you can prepare a table. There's another way of preparing a table. Let me show you that as well. Alright. Which is the divisor here? That 23. So write 23. You know first one, 23, 1 is 23. Now if you want to know what is 2 add 23. 6. Sometimes addition is easier for you. 46. You want to know 3 add 23. 69. 4 add 23. 92. 5 add 23. 115. 6 add 23. 138. 7 add 23. 161. 8 add 23. 184. 9 add 23. 207. Now you might think 23 tens is 230. 230, what do you know that? Everyone knows. But still, God knows if you have made mistake in addition. To confirm that you have not made mistake, add the last one also, 23. And what is that? 230. That makes us sure that we have not made any mistake. Now table is ready, so now division is going to be very easy. Well, divisor is 2-digit number, so select 2-digit which is bigger than 23, so it is divisible. Go across the table from top to bottom and find out the product which is greater than 49. 23, 46 and 69. 69 is greater, so you cannot take 23 threes because 49 minus 69 is not possible. It will be negative. So what is chosen here? 2s are. So 23 2s are 46 minus 3 0. Bring down 8. Bring down 8. So now it's 38. Bolo, find out a number which is just greater than 38. 23 46. 46 is greater. You can't take 23 2s. So previous one 23 1s. 23 1s are 23. Now subtract 5 and 1. Bring down the next digit 0. Now it's 150, 3-digit number. Find out the number which is greater than 150. And that is 161. So you cannot take 23 7s are 161. Because not possible to subtract 161 from 150 in division. Correct? Okay, so what is chosen here? 138, which is just smaller than that. So 23 6 are 138. Subtract. Correct? So 2 1. There is one more digit and that is the last digit brought down. That is 123. Find out the number, 3-digit number just bigger than 123. Bigger than 123 is 138. So before that you take 5s. 5s are 115. Subtract this. 13 minus, this is 11, 0, 0. So what is the quotient? 2165. And what is the remainder? 8. But don't you think this is going to be very time consuming process? Yes. So is there any shortcut? Yes, you can do. Let's see that. Same one, 49803 divided by 23. Children, I am going to split. See here, the whole table of 23 was prepared. That means 10 multiplications or 10 times you added. Correct? Now you can do the same thing with few multiplications done. How to do it? Let's see. I'm going to split this. Now you don't know 23 ones are table. So I'm going to split that into two parts. Correct? Now this is underlined. I'm going to call this is main digit. Main digit. And this one I'm going to call unused digit. Unused digit. Alright? So, well, that unused digit has to be forgotten for a moment. Okay? And then you just have to say two ones are table. Now that main digit is of main number is of one digit. That is one digit is there. So choose only one digit. That is bigger. So say two ones are table till you get 4 or more. 2 ones are 2, 2 twos are 4. You got exactly 4. So 2 twos are. Here you got the idea of taking twos are. But you don't want 2 twos are. Your table is 23. So you just check 23 twos are 6 and 4. Now you can check. Yes, 23 twos are 46. 46 is okay. So twos are 46. And then you just minus this. Now this is 3 and 0. Bring down 8. Fine. You brought down the digit. So again division you do. You don't know 23 ones are table. So again the same trick. Say 2 ones are table till the first digit, which is bigger than 2. Say 2 ones are table till you get 3. 2 ones are 2. 2 twos are 4. 4 exceeds 3. So you can't take 2s are. So you got the idea. 2 ones are you have to take. We don't want 2 ones are. Our table is 23. So take 23 ones are. No need to multiply. 23 ones are everyone knows. 23 ones are 23. And then subtract 5 and 1. Bring down the next digit, which is 0. Now it is interesting. Alright. Again, you don't know 23 ones are table. Does not matter. Say 2 ones are table till you get 1. But 1 is smaller. So you can choose 2 digits. After choosing 2 digits, at least one digit should be left out. At least one digit. आप जब 2 digit choose करते हैं, उसके बाद एक digit रहना चाहिए. नहीं है तो you can bring it down. Okay? You can bring 1 digit. Okay? So compulsory after selection, एक कम से कम एक digit रहना चाहिए. Fine. So say 2 ones are table till you get 15 or more. 2 sevens is 14. 2 eights is 16. 16 is more. So you will have to take 2 sevens are. But I don't want 2 sevens are. I want to check what is 23 sevens are. 23 sevens are. 21 and a 16. 161. Oh, sevens are exceeds. 23 sevens are is 161, which is more than 150. So you can't take sevens are. So what is before 7? 6. So 23 6 are. 18, 1, 12 and 13. That is okay. So 6 are 138. 2 and 1. There is one more digit to be brought down, and that is the last division, last digit brought down. Okay. Okay. Again, 2 digits. You can't choose 1 because it is smaller than 2. So you are taking 2 digits and 1 digit is left. That is okay. Now say 2 ones are table. Okay. To get 12 or even more. 2 6 are 12. You are getting exactly 12. So 6 are. So you don't want 2 6 are. You want to know what is 23 6 are. And that is already multiplied. 23 6 is 138. Oh, 138 exceeds 123. 138, 123 is a bada hai. So you can't take. So you will have to take multiple 5. That is smaller than 6. 23 5s are. 5 3s are 15 and 11. That is okay. 5s are 115 and this is 8. So what is the quotient? 2165. And what is the remainder? 8. So here you have to do only 4 divisions. Did you see that? So this is little bit convenient. It's little bit tricky. And you can divide any of this easily. Let's see next. Second one, 92891 divided by 92. Correct? Well, I'm going to split this into two parts. I'm going to say 9 ones are table, which is very easy for me. I'll choose one digit here, which is also 9. Yes, it's not smaller, so only one digit is chosen. Alright, after that digit should be left. After that we have 4 digits, so no problem. So say 9 ones are table till you get 9. What is 9 ones are? 9. But I don't, so it's going. 9 twos are 18. 18 exceeds 9. Okay? यहाँ सिलेक्ट 9 किया तो वहां तक ही लेना है या उससे बड़ा 9 2 18, लेकिन 18 9 से सब्ट्रैक्ट नहीं होगा, 9 में से सब्ट्रैक्ट नहीं होगा. करेक्ट? ओके, सो 9, बट आई डोंट वांट 9 ones are. That was just a trick to know 92 what za we have to take, right? So 92 ones are. Everyone knows what is 92 ones are. 92 ones are 92, and subtract this, that is 0. Bring down 8. 8 children, you brought down 8, but it is not divisible. देखो 9 से छोटा है, so bring down second digit. यदि दो digit simultaneously नीचे लाते हैं, if you bring the two digits simultaneously, then compulsory you have to put 0 there. Do you remember? Okay. Now fine. After bringing down 89, still it is not divisible. Check out. 92 ones is 92. So you are going to bring even the third digit, next digit. So again you have to put 0. And now check out. Say 9 ones are table till you get 89 or more. 9 tens are 90. 90 is more, so you can't take tens are. And you never take tens are individual. So what is before 10? 9s are. Let's check out what is 92 9s are. 18, 81 and 82. That's fair enough. It is small, correct? So 92 9s are 8 28. 11 minus 8 is 3, or 8 minus 2 is 6. Finished? Oh, all the digits are brought down. What is the quotient here? 1009. And remainder 63. Did you get it? All right. Now, third division. 69750 divided by 153. Well, children, here divisor is of 3 digits. Make 2 parts. One is too small, so we'll take 15 and 3. Yeah, you should know division up till 19 ones are. 1 to 19 ones are. You should know. Okay? चलिए, यहाँ 2 digit है, तो यहाँ 2 digit select करो. Yeah, 69 is bigger than 15, and after that some digits are left. So now start saying 15 ones are table till you get 69 or more. 15 fours are 60, 15 5s are 75. 75 is more. So you can't take 15 5s are. So what you should try? 15 fours are. But I don't want 15 fours are. My table is 153. So 153 fours are. 12, 21 and 6. 612. Okay, 612. One digit you have to select. After that, okay, 612. So what is 153? You are taking one extra digit, so one extra digit here also you have to take that after that. Sure. What is 153? Cosa 612. Subtract 5, 8. Bring down the next digit now. 5. Again the same story. Say 15 ones are table till you get 85 or more. 15 5s are 75 and 15 6s are 90. 90 is more, so you can't take 6s are. So 5s are, but I don't want 15 5s are. My table is 153. 153 5s are. 15, 1, 25, 26, 2 or 7. That's okay. So 153 5s are 765 minus 0, 9 and 0. One more digit to be brought down. Now it is 900. Say 15 ones are table till you get 90. 15, 2 digits, so 2 digits you select. 15 6 are 90. So 153 6 are. Let's check. 18, 31 and 9. Oh, it exceeds 900. So you can't take 6 are. So what should you take? 5s are. Already there. 5s are. 7, 6, 5. 10 minus 5 is 5, 9 minus 6 is 3, and 8 minus 7 is 1. So this is your remainder. So what is your quotient? 455. And what is your remainder? 135. I hope you understood that little trick. So only 3 divisions you have to do. In this case, only 1 division you need to do. Did you see that? Okay. So this is the shortcut by which you can divide any number by a 2-digit or 3-digit divisor. Is that clear? We are going to find HCF by Euclid's division lemma, and in that you have to do plenty of divisions. Okay, so let's see. Finding HCF by Euclid's division lemma, also called Euclid's algorithm. HCF by Euclid's division lemma or algorithm. All right. Okay. Correct. Let's see the first number whose GCD we want to find, the HCF. Question: find HCF by Euclid's division lemma, or sometimes they say Euclid's algorithm. Okay, the first number is 96 and 404. Clear? Okay. First, let us check out what is the HCF. HCF क्या है? By prime factorization method. 96. 2 48s are 2 24s are 2 12s are 2 6s are 2 3s are 3 1s are 404. 2 2s are 0s are 2s are 2 1s are 0s are 1. Now we know prime numbers up till 100 only. After 100, the very first prime number is 101. So 101 ones are. So 96. 2 is multiplied with itself 5 times, and 3 just appears once. 404. 2 is multiplied with itself 2 times, and 101 1 time. So what is HCF? What is HCF of these two numbers? Well, we have power with like base 2. The higher index is 5. The lower index is 2. So which is the power with lower index? 2 square. So 2 square, and that is 4. So what is HCF of these two numbers? 4. Remember, HCF of 96 and 004 is equal to 4. That you already know. But we used prime factorization method or the fundamental theorem of arithmetic, right? Now, how can we find using Euclid's division lemma? Children, out of the two numbers given here, which is bigger? Correct, 404. So that you take as dividend. Which is smaller? 96. That you take it as divisor. आ गया ना division? करना है ना अभी? चलिए, I'm taking this first digit now. So I'll take first digit here also, which is 4, which is smaller than 9. No, you have to select here, which is bigger than 9. So I'll have to take 2 digits. And after 2 digits, see, underlying digit is 1. After that, 1 digit is extra. Underlying digits are 2. After that, 1 digit should be extra. होना चाहिए. ज़्यादा हो तो कोई बात नहीं. Right? Then you start your multiplication. Check out. Say 9 ones are table till you get 40. 9 fours are 36. But I don't want 9 fours. My table is 96. So I'll try 96 fours are 24, 2 and 38. Yeah, it's divisible. So now see this. 4s are 384. 0, 2 and 0. Correct? Division is over. There are no more digits to be brought down. Correct? But you have to continue the division till you get remainder 0. Matlab, now you have to make another division. where the divisor of the previous one becomes dividend and the remainder in the previous division becomes divisor. Now this table is okay for you. 21s everyone knows, very easy. 20 fours are 80, so the remainder is 6. So second division is also over, but we didn't get the remainder 0, so we'll have to continue the division. In the next division, the divisor of the earlier division is going to become dividend and the quotient, the remainder is going to become divisor. Well, very easy division. Though you may not be knowing 16 ones are table, because of very small dividend, you can divide it easily. 16 ones are 16 and the remainder is 4. I didn't get the remainder 4, children. I didn't get the remainder 0. So I'll have to continue the division. In the next division, the divisor becomes dividend and this remainder becomes divisor. Come on, 4 fours are 16. And here's the good news. We got remainder 0. So you have to stop the division. Well, now where is Euclid's algorithm here? Where is Euclid's division lemma? I can't see anywhere. Here it is. First division, apply Euclid's algorithm. Division lemma. Dividend 404 is equal to divisor 96 into quotient 4 plus remainder 20. उसके नीचे ऑर्डर में लिखो, ऑर्डर में नेक्स्ट सेकंड डिवीजन का डिविडेंड 96 इज इक्वल टू डिवाइजर, आपको पहले डिवाइजर ही लिखना है, इनटू कोशेंट प्लस रिमाइंडर 60. उसके बाद ऑर्डर में नेक्स्ट डिवीजन 20, द डिवाइजर इज 20, दैट इज इक्वल टू 16 इनटू 1 प्लस 4, एंड इन द लास्ट डिवीजन 16 is the dividend, 4 quotient, 4 divisor into quotient is also 4 plus remainder 0. See, the last division that gives you remainder 0. What is the divisor in that case? Yeah, that's why I told you, first you should write divisor only. Then only you will know what is the divisor in the last case. And that divisor is HCF. Thus, HCF of 96 and 404 is the last divisor where you got remainder 0, 4. Check out, the divisor is 4. Got it? So this is Euclid's division lemma. Once again, कितने division करना है? सर कोई आसान सा तरीका है, लेकिन टाइम इतना ही लगेगा. Instead of doing division separately, you can do them together continuously. How? Let us see. So this is one way of doing it. Now let's see the second way. Correct? Okay. Fine, children. In this method, children, the division goes, it starts from left corner and moves towards right corner. Division ऐसे जाएगा. See now what happens. कैसे? So you have to start from left hand side and probably beginning of the page. आपका जो पेज की शुरुआत है वहां से शुरू करो. आधे पेज से शुरू करेंगे तो कभी जगह कम पड़ जाएगी. Right? So let's check. 404. I started close to margin. Divide by 96. I'm going to write quotient here, not up. I'm going to put quotient here. So I use new type of symbol. चलिए, same old story. 9 यहाँ 4 नहीं लेकिन 40. Same thing. 9 4s are 36. But I don't want 4s are, my table is 96. So I don't want 9 4s, I want 96 4s. What is 96 4s are? So 24, 36 and 38. So what is 4s you write here? 384. Well, I have to subtract this. So that gives me 20. See what I am doing here. This is remainder. It becomes divisor. And the earlier divisor becomes dividend. And form that symbol. Continue the division. 20 4s are 80. Subtract. That is 16. This remainder becomes divisor. And the earlier divisor becomes dividend. Now divide. 16 ones are 16. Subtract. 4. Division is over. This divisor, that is remainder becomes divisor and earlier divisor becomes dividend. 4 4s are 16 and remainder is 0. And you get remainder 0. That is good news for us because the division stops. Okay. Now Euclid's algorithm. इसके नीचे आपको लिखना है. First, बताइए 404 is equal to divisor into quotient 96 into 4 plus the remainder 20. Next, what is the dividend? 96 divisor into quotient 20 into 4 plus the remainder down. Next, dividend divisor into quotient, that dividend 20 is equal to divisor into quotient 16 into 1 plus the remainder 4, and the last dividend 16 is divisor into quotient 4 into 4 plus 0. ये 4 remainder 0 आया, so that divisor is your HCF, the last divisor. Thus HCF of 96 and 404 is equal to 4. So that is HCF using Euclid's division. Okay students, so we have learned how to find HCF by Euclid's division lemma. Alright, will you be able to do? Well, not yet. So for more consolidation of the work, let us see 2 more examples. Let's find out HCF of 38,220 and 196 by Euclid's division lemma. It's also called Euclid's algorithm. Okay, we'll use the division method. You know, from left to right, cross the division goes. Correct? Okay, so I'll start from the margin. This is solution 2. And the smaller, okay, I'll put that sign. The smaller number is 196. It goes as divisor. The larger number goes down as dividend. Alright. Now it's time to divide. The table you need to know is 196, which is difficult. So what we do, we'll consider first 2 digits. 19. 19 is okay. You should know tables up till 19 ones are. Alright. Fine. Here I choose 2 digits and that is 38. Yeah, 38 is bigger than 19. So, if 19 is chosen from divisor, 38 is chosen from dividend. Okay. After 19 we have 1 digit. So, in dividend also after 38 we have to take, consider 1 more digit, extra digit. So, here when you say 19 ones are table, consider 38. And when you consider 196, here you consider 382. Okay, got that? So let's start. Say 19 ones are table till you get 38, and it is 19 twos are. Here we got the idea, we have to take twos are, but we don't want 19 ones are. Our table is 196. So let's find out 196 twos are 12, 19, and 3. You can do that multiplication. So it's 392. 196 twos are 3. I'm sorry. 392 is greater than 382. So it's not divisible. If it is not divisible by 2, you have to consider the divisibility by 1. So, and 196 ones are, everyone knows. 196 ones are 196. Subtract this. 12 minus 6 is 6. 17 minus 9 is 8. 2 minus 1 is 1. Bring down the next digit and that is 2. So now you have 1862. Well, if you choose 2 digits It is smaller than 19. So you have to choose 3 digits. So now you have to say 19 ones are table till you get 186. Yeah, after 19 one digit is extra. So after 186 also one digit should be extra, and it is there. Now 19 into what is 186 or more than 186? So you have to say the table. I'll say directly 19 nines are. What is 19 nines are? 9 tens are 90 and 9 nines are 81. So 90 plus 81 is 171. Yeah, okay. 171 is okay. So you can take 9s are, but I don't want 19 9s are. I want to know what is 196 9s are. 9 6 are 54, 5. 9 9s are 81. 81 plus 5 is 86. Carried over 8. And that is 17. Fine. That is okay. So 196 9s are how much? 176, 4. Subtract. This is 8. 15 minus 6 is 9. And this is 0 and 0. One more digit is left out. Children, this is simple division that we are doing. We didn't get the final remainder yet. Okay? Chaliye. Fine. The same trick. If I choose 2 digits, it's 98, which is bigger than 90. And one more extra digit is there. So no problem. Say 19 ones are table till you get 98. Well, you say the table and find out. 19 5s is 95 and 19 6s is 114. So that is extra. So 5s are 196, 5s are 30, 3, 48, 4 and 9. Oh, that is exactly divisible. So 196, 5s are 980. Subtract this and that is 0. 0, 0, 0, 0. Correct? Oh, you are very lucky. You got 0 in the first division itself. So what is your divisor? When you got remainder 0, 196. And that is HCF. Correct? Okay. Let's represent in the Euclid's division lemma form. Dividend 38220 is equal to divisor into quotient. Divisor is 196 into quotient 295 plus the remainder 0. You got remainder 0 when the divisor was 196. So the HCF is 196. Thus, HCF of two numbers 38220 and 196 is equal to 196. Got it, children? Done? One more sum, the third one. Alright? Well, I'll put that division sign. The smaller number 4052 and the larger number 12576. Here you will see it's very lengthy division. I know that. I'm telling you. Just observe and understand. Okay? Now, here I'll take only one digit. That's okay. If I take one digit, it is 1. So I'll have to choose 2 digits, 12. That is greater. After one digit, there are 3 more digits. So after this 12, there should be 3 more digits. And there are 5. So you can divide. Say 4 ones are table till you get 12. 4 3s are 12. But I don't want 4 3s are. What I want is 4 0 5 2 3s are. Let's see. 6, 15 and 12. Is that okay? Yes. It's divisible. So let's take 3s are 1 2 1 5 6. Subtract 0 2 4 and this is 0 0. You may write, you may not write. But you didn't get the remainder 0, so the division will continue. See now, this becomes divisor and the earlier divisor becomes dividend. Correct? Now, see this. 4 ones are table till you get 4. Yeah, 4 ones are is 4 only. But after that you have to take 2 digits. After 4 you have 2 digits. So after 4 you have to consider 2 digits. So that is 405. 405. So 420. 1 is 420. It's not divisible. If you want, you can divide. If it is not divisible by 1,
you can divide by 0. So 420 zeros, everyone knows. 420 zeros are 0. Subtract 5, 0 and 4. Now you bring down 2. Children, in the beginning, if you don't take 0, it's okay. But I don't want you to make any mistakes. I'm putting 0 here. Alright? Chal. Now 4 and 40 you will have to take, because after underlined digit we have 2 digits. So whatever is underlined, we should have 2 digits left after that. Okay. Say 4 ones are double till you get 40. 4 tens are. But you never take tens are. So 4 nines are. But I don't want 4 nines are. What I want is 429s are. So let's find out. 429s are. 9 zeros are 18 and 37. That is okay. Correct? So 429s are. This 0 you may write, may not write. Children, I'll explain to you here once again. If you don't want to write 0, what happens now? 1 digit, 1 digit. Correct? 4 ones are 4. 420 ones are 420. But that is bigger than 405. So you have to take one more digit. You have to take 1 digit extra. So you are taking 1 digit extra. Correct? So you have to put 1 0. But in the beginning we did not put 0. Alright? So if you put 0 or do not put 0, it's okay. So now you have to consider, you took 1 extra digit, so you take 1 digit extra here also. So say 4 ones are double till you get 40. 9s are. And what is 9s are? Alright. 9s are 3780. 2. Correct? Then 7, 2 and 0. So remainder is not yet 0. So this remainder becomes divisor, and earlier divisor becomes dividend. 2 and 4. 2 2s are 4. 2s are लेना है, लेकिन टेबल है 272. 2s are 4, 14 and 5. Oh, that exceeds. So 272 2s are नहीं ले सकते. Then we will take 272 ones are, and everyone knows that table, right? 8 and 4 and 1. Still, there is no good news. The remainder is not yet 0. So division continues. Let's continue. This is how you extend the symbol. The earlier divisor was 272. Here I'll have to take 2 digit. 1 हो तो 2 digit लेना पड़ेगा. तो यहाँ भी 2 लेंगे. 14 2s are 28. 2s are भी नहीं जाने वाला है. So 1s are. Alright. And 148 1s are is 148. See how the division goes from top left hand to right bottom end. Correct? Okay. 12 minus 8 is 4. 6 minus 4 is 2. And 1 minus 1 is 1. Alright. Sorry. 2 minus 1 is 1. No 0 yet. So continue the division. It is 148. Simple. 3 digit, 3 digit. 124 ones are. 124 minus 4, 2. No 0 yet. Continue. The earlier divisor. 124. Well, here you see now. 2 ones are, 2 6 are 12. So you may try 6 are. 24 6 are. 24 and 14. 144, which exceeds 124. It's greater than 124. So we can't take 6 are. So let's take 5 are. 120, right? So that is okay. 24 5s are. 120. And the remainder is 4. No 0 yet. No good news. Now divide by 24. 4 6 are 24 and 0. Ultimately, we are getting the good news. The remainder is 0. This is the last division that we did, in which we got remainder 0. So the last divisor is 4. So HCF of these two numbers is 4. But we'll have to express this in Euclid's algorithm form. Yeah, Euclid's division lemma. So what is the first dividend? 1, 2. Now, 1, 2, 5, 7, 6 is equal to divisor into quotient 4, 0, 5, 2 multiplied by 3 plus the remainder is 420. Second, 4, 0, 5, 2 is dividend. divisor into quotient 420 into 9 plus the remainder 272. Third division, 420 is the dividend, divisor into quotient 272 into 1 plus 148. Correct? Next division, 272, divisor into quotient, that is 148 plus 1, into 1 plus the remainder 124. Next division, 148, that is divisor 124 into quotient 1 plus the remainder is 24. Next division, 124 is equal to divisor 24 into quotient 5, 24 into 5 plus the remainder, that is 4. And the last division, 24 is equal to divisor 4 into quotient 6, 4 into 6 plus the remainder, that is 0. Thus, HCF of 4052 and 12,576 is equal to, what is that? 4. Got it, children? Sure. Now, next concept we are going to see is how to make use of representation of integers using Euclid's division lemma. Okay, students, but that we will see in the next video. So this video will end here. The session continues. All right. Goodbye.